So morning to everyone. As Boris mentioned, I participated in the chapter 10 of the last IPCC report, which is called Linking Global to Regional Climate Change. And basically this chapter treats the title of my presentation today: how do we construct regional climate information that is relevant for risk assessment and decision making? So a lot from the presentation will be from the chapter. So the outline of the talk is as following: how the values and context influence in the construction of information, and why should we make them explicit? I will present what we call the distillation approach to climate information construction, and then I will try to explain what a storyline is and why it is useful for risk assessments and regional decision making. So to understand a new approach, it's useful to contrast it against the old approach, so to say. So here I show the traditional knowledge supply chain approach, where a user contracts a service from the scientist. And once that is done, the scientist has the control of the whole process of production or extraction of data, processing the data, and preparation of the communication material. So the problem with this is that the choices and assumptions are based on the values of the scientist, which can lead to misunderstandings of how to interpret the information, and the information might not be optimally useful for the risk assessment and decision making that the user wanted to have it for. So what are those values that I mentioned? We tend to think of climate science as objective and without values. So I will just give a very simple example just to illustrate what kind of values we face almost on a daily basis, I would say. So here is the scientist, and she is struggling to decide which emission scenario to use when producing future climate information. She can't use all of them because she has limited resources. So when talking to colleagues from her lab, she got different views. So the traditional climate scientists want to use strong emissions, large emission scenario, because that will give a strong regional climate signal in the climate model. The politically engaged climate scientist will want to have scenarios that are consistent with the Paris Agreement, because otherwise, if we don't include them, we will send a wrong signal to the policymaker, and we will sort of say that we don't think that the Paris Agreement is achievable. Then we have the prudent climate scientist that wants to use the 4.5 scenario, the middle of the road scenario, because it just seems to be more likely, it's in the middle. Okay, so this is a very simple example. I think we all can relate to this. But also context of both the scientist and user influences in the construction of climate information. So now again, a very simple example to understand what the context can be is the example of the temporal scales. So as an example here, I used the temporal scale of the latest IPCC report. We used 20-year long windows to represent the near term, mid-term, and the long term. And as you are probably aware of, traditionally, climate science has focused on the long term, so the end of the century. But that is not, even if it gives a very large signal of climate in the models and everything, it's not very useful for the policy making. On the other hand, we know that the near term is very challenging due to the internal variability, and we can't even distinguish well between the different scenarios when we look at the global surface temperature. So this is a very challenging time window. The midterm, the mid of the century, is now given more attention, for example, by IPCC. And this is because I think that some users require it, mostly the infrastructure section in developed countries. But we have still issues with the useful timescales. There's a mismatch in timescales of climate information and political cycles. This is particularly true for developing countries. In a review article by Singh et al., they found that in Africa and India, there are very few clear examples of long-term climate information being used to inform decisions. And the successful examples they found of climate or weather information being integrated in decision makers used timescales on week to seasons. Okay, so these were two examples on values and context. But there are many more areas where choices are influenced by the values and context. For example, very important for us as climate scientists is the selections of sources of information. So, for example, the types of information, what do we have available for the region we want to study? What type of information is the scientist familiar with? Then we have the dynamical models. We have the statistical downscaling, the different methods there. We can use process understanding, we can use attribution, even we can use user knowledge and indigenous knowledge when we produce climate information. So there are a lot of areas where choices are influenced by values and contents, and I really recommend, if you're interested in this, to have a look at chapter 1 and chapter 10 of the report of IPCC. So now we are going to look at the distillation approach. So this is an alternative to the linear supply chain approach. In chapter 10 of the report of IPCC, we found that the literature around useful regional climate information proposed what we call a distillation approach. So if you have a look at the chapter, you can download it from the IPCC page, you see that this is the first figure of the chapter, but it's not very apt for PowerPoint presentation, unfortunately. So I will present the key elements in bullet points to you now. Climate information is co-produced together with the user, considering the values and the context of everyone involved in the process. Next, on sources of information, start off with an open mind of what sources of information you can use, and use all sources of information available that are relevant for the context or fit for purpose. Then the climate information is distilled or synthesized from the different sources. And this can be in form of storyline, graphics, data with uncertainty estimates. And lastly, the user-oriented climate information for communication is produced. So by this, I mean for divulgation of the results. So I just also want to mention that it is important to notice that although these are well-defined steps, this process is not linear, but it is circular. So we can go through these steps over and over again and keep learning together with the user of the information. So now I will use the rest of the talk to talk about storylines, because this is a new concept that is, well, new at least for climate scientists, and it's being used a lot in the community. Okay, so what is a storyline? So here we have the definition from the IPCC AR6 glossary. It's a way of making sense of a situation or a series of events through the construction of a set of explanatory elements. Usually it's built on logical or causal reasoning. So there's a lot of different examples on storylines. Please have a look at these references here if you are more interested, or we can discuss it in the Q&A. I will focus mostly on the dynamical storylines due to time limits. So just a bit of background to why storylines is thought to be needed. We have high confidence in thermodynamic aspects of climate change, such as global warming, sea level rise, or atmospheric moisturing. But the dynamical aspects of climate change are much more uncertain. So projected changes in large-scale circulation differ a lot amongst models and gives high uncertainty in future regional precipitation changes. Here, there's just a showcase of this. Don't care about the region. This happens in a lot of regions all over the world. So this is an example from the chapter 10 again, where we show an ensemble where we use 2 RCMs, 2 regional climate models, and 2 global climate models to downscale this area. And we see that we get very different results in the precipitation. This is not only true for downscaling, but we get it in the global climate model simulations as well, for example, in the CMIP models. And we are used to represent it in this way, something like this, a time series with a multi-model mean and an uncertainty estimate, or as here, we've just plotted all the results of all the models. But there are several problems with this way of representing the results. The model mean can be close to 0, but that doesn't mean that the future risk is low. And actually, the multimodal mean shouldn't be interpreted as the best estimate of climate change. But furthermore, and this is very interesting, because social scientists have found that communication of the full range of outcomes and uncertainty can be a barrier to the uptake and use of the results. So that is why we try with storylines. And this is a causal network that we use to describe the concept of the storyline. So here we can have some elements that we block. We can specify some elements. We can have leave some elements variable. And what we look for is actually information about the impact, because we are interested in know what future impact will be for the regions. So the impact is composed by the exposure and the vulnerability and the hazard. And as climate scientists, we work with providing the hazard to this equation. So in the dynamical storyline, we decide to fix the global warming to a certain level. We know that global warming depends on climate sensitivity and climate forcing, but we don't care about these elements because it gives us a large uncertainty. We just say, okay, let's look what happens at this global warming level. And then this global warming level can lead to different changes in the remote drivers. So we decide to study some of the changes that can happen in the remote drivers. So we fix these remote drivers at different conditional possible future, right? And then we look at what happens with the dynamical condition, the regional warming, and how these produce the hazard that we are interested in.
Anna, you have 2 minutes left.
I will give a practical example of a storyline that we used in an attribution example in chapter 10. This is about past multi-decadal increase in summer rainfall in Southeast and South America. In this case, the climate forcing is both natural, it's the Atlantic multi-decadal variability, and human in the form of greenhouse gas forcing and stratospheric ozone depletion. Here are the remote drivers and the dynamical condition that leads to the hazard, in this case, the increased summer rainfall. So this example was created to think about and explain and make visible the different drivers of the present situation, but we can also play around and use it to think about future changes. For example, we expect the stratospheric ozone depletion to decline in the future. So this particular forcing will be less and less and contribute less to this branch. So there's a lot to say on storylines, but my time is running out. So I'm just going to summarize this by giving some regional climate information key messages. So make values and context explicit and take into account the values and context of all actors. Let the context and the fitness of for purpose guide the selection of sources of information. Storylines are tools for studying and communication regional climate change that make sense of a situation or a series of events. So thank you very much. Stop here.